The language barrier of the universe. In the vast expanse of space, where stars outnumber grains of sand on Earth, the idea of encountering extraterrestrial life had always been more than a scientific hypothesis. It was a dream, a hope, and for some, a fear. When humanity first detected the faint, rhythmic signals from Proxima Centauri, the universe became smaller and infinitely larger all at once. The realization dawned: we were not alone. Introducing the concept of interspecies communication. The greatest challenge wasn't traveling the 4.2 light-years to Proxima Centauri b. Advanced telescopes, quantum communications, and autonomous probes made the distance less daunting than it once was. The real challenge lay in understanding what those signals meant. They were undeniably structured, too deliberate to be natural phenomena. But their patterns defied Earth's linguistic norms. Earth's leading linguists, mathematicians, and cryptographers formed a coalition, the Interspecies Communication Initiative, ICA. The team analyzed the signals around the clock, attempting to decode their meaning. Would mathematics serve as the universal language? Could patterns of light, sound, or electromagnetic pulses bridge the chasm between species? Or were humans arrogantly projecting their own biases onto an alien mind? We must consider that their concept of communication might be utterly alien. Dr. Yara Mendel, a leading xenolinguist, cautioned during a press briefing. Their senses, their culture, even their perception of time and space, everything could be fundamentally different from ours. Exploring communication with extraterrestrial life. The ICA's first breakthrough came 6 months after the signals were discovered. A repeating series of prime numbers was detected, numbers that suggested intent, intelligence, and a shared grasp of basic mathematics. It was a starting point, a Rosetta Stone of sorts. Encouraged, the team sent a reply, encoded in pulses of light and bursts of radio waves. They included a sequence of prime numbers, followed by basic mathematical operations, a simple visual representation of the solar system, and images of DNA helixes, an invitation to begin a dialogue. Weeks passed, then months. When a reply came, it was baffling. The patterns they received were incomprehensible. The signals seemed like gibberish to Earth's finest minds, with no discernible structure, no patterns akin to human logic. What if their biology dictates their form of communication? Dr. Mendel proposed at an emergency meeting. They might not use vision, sound, or touch as we understand them. Their equivalent of language could be chemical signals, magnetic fields, or something we can't even detect yet. Cultural, evolutionary, and biological differences. The alien species, dubbed the Luminae by the media, was as enigmatic as their signals. Analysis of their planet suggested an environment vastly different from Earth, a dimly lit world bathed in infrared radiation, with a dense, methane-rich atmosphere and gravity twice that of Earth's. Any life that evolved there would have followed a path foreign to terrestrial biology. Imagine trying to explain Shakespeare to an octopus. Mendel said during a media interview, "Now imagine that octopus lives in a reality where concepts like sight and sound don't exist. That's the magnitude of the challenge we're facing." The Luminae likely didn't share humans' reliance on vision or sound. Their signals might represent sensory input unique to their environment. Pulses of heat, shifts in pressure, or even subtle quantum-level vibrations. How could humanity hope to interpret their language, when even the concept of language might be alien? First steps toward understanding. The breakthrough came not from linguists or cryptographers, but from a theoretical physicist, Dr. Kavita Sharma, who proposed an entirely novel approach. By modeling the signals in a four-dimensional mathematical framework, the team discovered an underlying rhythm, a pattern that suggested not words or sentences, but a kind of emotional or conceptual intent. It wasn't a language in the human sense, but a symphony of meanings, conveyed in ways that transcended the senses. Using this model, the ICA crafted a response, one that expressed humanity's curiosity, peace, and willingness to learn. The signal was sent, and this time, The reply was unmistakably positive. The Luminae signals shifted, their patterns growing more intricate, as if they, too, were attempting to bridge the divide. The challenges persist. Even with this tentative connection, countless questions remained. What if the Luminae had no concept of individuality or identity? What if their messages were not intentional communication, but something akin to involuntary biological processes? The potential for misunderstanding was immense. Yet, as humanity looked up at the night sky, the stars seemed brighter than ever before. The effort to understand the Luminae wasn't just about deciphering alien signals. It was about redefining the limits of human thought, empathy, and imagination. If communication could be achieved, it would mean more than simply talking to another species. It would mean proving that the universe itself wasn't too vast for connection. The universe had thrown down a challenge: to reach across the cosmic void and grasp the hand of the unknown. And humanity, resilient and curious as ever, accepted. Decoding alien signals, the signals from Proxima Centauri, continued to pulse across the vast gulf of space, teasing humanity with their enigmatic patterns. The rhythm and structure hinted at intelligence, but the meaning remained maddeningly out of reach. The Interspecies Communication Initiative, ICA, faced the most formidable challenge in humanity's history: decoding the intentions of a species utterly alien in every conceivable way, exploring different forms of communication. Early efforts to decipher the Luminae signals assumed that communication would be grounded in forms familiar to humans, visual patterns or auditory frequencies. This assumption, however, quickly proved inadequate. The Luminae's transmissions didn't align with any single sensory modality. Instead, they seemed to encompass a complex interplay of variables, as though their language operated in dimensions beyond human comprehension. Dr. Kavita Sharma suggested the possibility of multisensory communication. The Luminae might combine sensory inputs in ways we can barely imagine. She explained during a conference. They could be using something akin to a symphony: notes of heat, light, magnetism, and pressure, all woven together into a coherent message. Even more speculative was the theory proposed by neurobiologist Dr. Marcus Lin. What if they communicate telepathically? Not in the science fiction sense, but through direct transference of concepts or emotions using bioelectrical or quantum mechanisms. The notion of telepathic-like communication was intriguing but impossible to test. For now, the focus remained on what could be analyzed: the signals themselves. The difficulties of deciphering alien signals. The Luminae signals were complex and layered, exhibiting patterns that defied human linguistic norms. Their syntax, if it could be called that, was non-linear, with elements that repeated, merged, or evolved over time. Attempts to map these patterns to known languages or symbolic systems failed. No amount of cross-referencing with human alphabets, numbers, or pictograms yielded results. This isn't just about translation, Dr. Yara Mendel explained during a team meeting. Translation assumes a shared context, a common ground. But the Luminae don't share our evolutionary history, our sensory systems, or our cultural framework. We might be trying to decode the equivalent of a smell using only visual tools. Compounding the difficulty was the question of intention. Were the signals a deliberate attempt at communication, or were humans interpreting natural phenomena as language? The prime numbers in the initial message strongly suggested intelligence, but subsequent transmissions were so alien in structure that doubt crept into the minds of even the most optimistic researchers. To address these challenges, the ICA assembled a diverse team: mathematicians, physicists, biologists, anthropologists, and even artists. Each discipline brought a unique perspective, hoping to illuminate a fragment of the puzzle. The role of sophisticated technology. Breaking the communication barrier required innovations that pushed the limits of current technology. Quantum computing arrays processed the vast streams of data, searching for patterns across dimensions humans couldn't perceive directly. Artificial intelligence algorithms simulated countless possible languages, testing each against the Luminae signals to identify any matches. The ICA also developed novel tools, such as the resonance translator, a device capable of converting non-auditory signals, like electromagnetic waves and pressure pulses, into interpretable forms. The device allowed researchers to listen to the Luminae signals in ways that transcended traditional auditory methods. One breakthrough came when researchers began analyzing the signals as holographic constructs rather than linear sequences. By mapping the data into three-dimensional space, they uncovered intricate patterns resembling fractals. These fractals, when modeled in real time, seemed to change in response to Earth's signals, a hint that the Luminae might be adapting their communication to bridge the gap. A new approach. Frustration grew as months passed with no definitive answers. Then, Dr. Sharma proposed a radical idea. Instead of trying to understand the Luminae signals, what if humanity sent them something completely different? A universal constant, such as the Fibonacci sequence or the golden ratio, encoded not just in numbers but in multiple sensory formats: light, sound, and magnetism. Let's see if they recognize it, Sharma argued. If they respond in kind, it could establish a baseline, a shared point of understanding. The team crafted a new message, a multi-layered transmission combining mathematical constants, visual representations, and auditory frequencies, all tied together with a repeating fractal structure. The message was broadcast using Earth's most powerful quantum communication arrays. The Ripley days turned into weeks as the team waited for a response. When it came, it was unlike anything they had received before. The new signal mirrored humanity's transmission, but with subtle alterations. The Luminae had clearly recognized the patterns and adapted them, introducing new elements that hinted at a deeper complexity. "This is it," Mendel whispered as she examined the data. "This is a dialogue." The Luminae's additions to the fractal structure appeared to convey new information, though what that information was remained unclear. But one thing was certain: the Luminae were trying to communicate. The challenge now was deciphering their additions without misinterpreting their intent. The horizon ahead. As the ICA continued their work, the enormity of the task became clearer. The Luminae signals represented more than a language. They embodied an entirely alien way of perceiving the universe. To truly understand them, humanity would have to think beyond its own limits, embracing a level of innovation, empathy, and open-mindedness that had never been required before. The communication barrier wasn't just about understanding the Luminae. It was about redefining what it meant to communicate, and perhaps what it meant to be human. Bridging the gap, overcoming linguistic hurdles. The first steps toward understanding the Luminae's enigmatic signals had been taken, but a true dialogue was still far out of reach. The Interspecies Communication Initiative, ICI, understood that progress required not just technological sophistication, but creative and empathetic approaches that transcended traditional methods of communication. Nonverbal communication as a potential bridge. As researchers considered alternative modes of interaction, they turned to the most primal form of communication: nonverbal cues. On Earth, body language and gestures had often bridged linguistic divides between human cultures, and similar principles might apply to the Luminae. But how could nonverbal communication work with beings whose biology and perception were utterly foreign? The Luminae's homeworld, with its dense atmosphere and dim light, suggested that their visual cues, if they had any, might rely on infrared or thermal variations. To test this hypothesis, the ICI sent a series of infrared signals that mimicked the ebb and flow of earthly gestures: greetings, affirmations, and invitations. Each pattern was carefully designed to convey intent rather than meaning, much like the open-palmed wave that universally suggests peace among humans. The Luminae responded in kind. Their signals changed in subtle ways, as if they were mimicking or acknowledging the thermal gestures. While the significance of these changes remained unclear, the interaction was a milestone. It suggested that the Luminae recognized intent and were willing to engage. This could be their equivalent of a handshake, Dr. Yara Mendel remarked, her excitement tempered by caution. "It's a start, But we're walking a tightrope. Missteps could lead to misunderstandings. Universal concepts as a starting point. To establish a foundation for deeper communication, the ICA turned to universal constants, concepts that should, in theory, be understood by any intelligent species, regardless of biology or culture. Mathematical equations, such as the Pythagorean theorem, were encoded into pulses of light, sound, and electromagnetic waves. These were accompanied by visual representations of fundamental physical laws, including Newton's laws of motion and Einstein's equation, E equals Q2, E equals mc 2. The Luminay's responses were fascinating. Their signals incorporated the mathematical sequences, but added layers of complexity, patterns that hinted at their own understanding of the universe. For example, they transformed the Pythagorean theorem into a fractal structure, suggesting an advanced grasp of geometry that extended beyond human conventions. What if they're teaching us? Dr. Marcus Lynn suggested during a late-night strategy session. These aren't just responses, they're elaborations. They might be showing us how they think about the same concepts. The possibility that the Luminae were actively sharing knowledge electrified the team. They shifted their approach, focusing on creating signals that invited collaboration rather than simple responses. For instance, they transmitted an incomplete equation, hoping the Luminae would provide the missing components. When the reply arrived, it contained not just a solution, but an entirely new perspective on the problem. An alien interpretation of mathematics, cultural sensitivity, and empathy in interspecies interactions. As progress continued, the ICA faced a sobering reality. The Luminae's responses were not just data, they were glimpses into an alien culture. Their fractal representations, layered patterns, and multidimensional signals hinted at a civilization shaped by values, priorities, and experiences that humans could barely imagine. We can't approach this with a colonizer's mindset, Mendel emphasized during a team briefing. We're not here to impose our way of thinking or extract knowledge. This is a partnership. We need to meet them halfway. Empathy became the guiding principle of the mission. The ICI established a framework for interpreting the Luminae signals that prioritized context and intent over direct translation. Psychologists and anthropologists joined the team, analyzing the signals for signs of emotional resonance or cultural motives. The team also began considering how their own messages might be perceived by the Luminae. Would images of humans be seen as threatening? Would certain patterns or frequencies be interpreted as hostile? Every transmission was carefully vetted to ensure it conveyed respect and curiosity. A moment of connection. After months of cautious exchanges, the ICI decided to attempt a bolder experiment. They created a cultural capsule, a compilation of Earth's music, art, and imagery, encoded in forms that the Luminae might perceive. The capsule included representations of human achievements, such as the pyramids of Giza and the International Space Station, alongside depictions of natural beauty, like Earth's oceans and forests. When the Luminae's response came, it was stunning. Their signal included a fractal representation that, when rendered into 3 dimensions, bore a striking resemblance to the Fibonacci sequence, a universal pattern found in nature. Embedded within it were variations that seemed to echo elements of humanity's cultural capsule. They're not just acknowledging us. Sharma whispered as she analyzed the data. They're sharing something of themselves. The fractal structure contained embedded patterns that, when analyzed, appeared to depict natural formations on Proxima Centauri, perhaps the Luminae's own oceans, landscapes, or even structures. The implications were staggering. Humanity and the Luminae had found a common ground in the shared language of nature and art. Toward the future. Bridging the gap between humanity and the Luminae was an ongoing process, fraught with challenges and uncertainties. But the progress made so far was proof that understanding was possible, even across the vast chasm of evolutionary and cultural differences. This is bigger than science, Mendel said during a press conference. It's a testament to what's possible when we approach the unknown with curiosity, humility, and empathy. The Luminae have shown us that, despite our differences, we can connect. The universe, vast and indifferent as it sometimes seemed, had offered a hand. And for the first time, humanity was beginning to grasp it. The impact of first contact, a new era of understanding. The moment humanity realized it was not alone in the universe, history bifurcated. Every decision, every perspective, and every system that had shaped human civilization was now re-examined in light of the existence of the Luminae. The successful exchanges between the Interspecies Communication Initiative, HFY, and the beings of Proxima Centauri, B marked the beginning of a new chapter for Earth, a chapter filled with promise and peril, social, political, and philosophical implications. The confirmation of extraterrestrial intelligence sent shockwaves through societies across the globe. For many, it was an exhilarating affirmation of humanity's place in the cosmos. For others, it was a deeply unsettling reminder of how small and vulnerable Earth truly was. Religious and philosophical institutions grappled with the revelation. Some interpreted the Luminae as proof of divine creation on a cosmic scale, while others questioned long-held beliefs about humanity's uniqueness. Theologians debated whether humanity's moral framework extended to alien species, while existentialists pondered the implications of shared sentience across the stars. Politically, the first contact catalyzed both cooperation and tension. Nations that had long competed for dominance in space exploration were now forced to collaborate, pooling resources and knowledge to engage with the Luminae responsibly. The United Nations established the Office of Extraterrestrial Affairs, OEA, to coordinate humanity's interactions with the Luminae, though rivalries occasionally flared over who should represent Earth's interests. Public opinion was divided. While many celebrated the milestone as a triumph of science and diplomacy, others feared the unknown. Were the Luminae truly peaceful? Could their advanced technology threaten Earth? Conspiracy theories proliferated, as did calls for transparency in the IC's operations. Advancements in technology, science, and culture. As the exchanges between Earth and the Luminae deepened, the potential for shared knowledge became apparent. The Luminae's understanding of physics, encoded in their fractal signals, suggested technologies far beyond human capabilities. Engineers and physicists worked tirelessly to decode these concepts, leading to breakthroughs in energy efficiency, quantum computing, and material science. One of the most transformative developments came in the form of propulsion technology. By interpreting Luminae data on gravitational manipulation, scientists developed a prototype drive system capable of reducing interstellar travel times to mere decades instead of centuries. This marked the dawn of humanity's true expansion into the stars. Cultural exchanges also flourished. Artists drew inspiration from the Luminae's fractal patterns, incorporating them into music, architecture, and visual art. The Luminae's apparent appreciation for symmetry and natural forms influenced everything from urban design to clothing. Meanwhile, humanity shared its own cultural treasures, offering the Luminae glimpses of Earth's diversity and creativity. Education systems worldwide were overhauled to include the study of xenolinguistics, interspecies ethics, and galactic diplomacy. Young minds were taught not only to dream of exploring the stars, but also to consider their responsibilities as stewards of a shared universe. Ethical considerations and the impact on society. The ethical implications of first contact were profound. Humanity had to confront questions it had never seriously considered before. Should Earth's technology and resources be shared with the Luminae, and vice versa? How could humanity ensure that interactions were equitable and respectful, avoiding the mistakes of colonialism and exploitation that marred human history? What if humanity inadvertently harmed the Luminae's way of life or environment? The ICI established strict ethical guidelines for all interactions, emphasizing transparency, consent, and non-interference. A committee of philosophers, scientists, and cultural representatives from around the world was formed to evaluate each new development. ensuring that humanity's actions aligned with these principles. Despite these efforts, tensions arose. Some factions argued that humanity should focus on solving its own problems, climate change, inequality, and conflict, before engaging with alien species. Others feared that shared technology from the Luminae could disrupt Earth's economies, exacerbating existing divides between nations and social classes. Yet for many, the lessons of first contact were humbling and unifying. The Luminae's existence underscored the fragility of Earth and the interconnectedness of all life. Global movements for peace and environmental stewardship gained momentum, driven by a newfound sense of cosmic perspective. The dawn of a galactic era. The first direct message from the Luminae, fully decoded after years of painstaking effort, encapsulated the heart of this new era. It was not a directive or a demand, but an invitation, a call to collaborate, to share knowledge and experiences, and to explore the universe together. The message closed with a symbol, a fractal pattern that, when rendered visually, resembled two hands reaching toward each other. It was an unmistakable gesture of unity and hope. This is what it means to evolve, Dr. Yara Mendel declared at a global broadcast celebrating the milestone. To step beyond fear and ignorance, to embrace the unknown, and to recognize that we are part of something greater than ourselves. The era of isolation was over. Humanity had found its voice in the cosmic choir and, for the first time, truly understood the power of connection. The road ahead would not be easy, but it was a road worth traveling, a path toward understanding, growth, and the boundless possibilities of the universe. The future of intergalactic dialogue. The discovery of the Luminae. The questions extended beyond the Luminae. If other intelligent species existed in the universe, what forms might their communication take? How could humanity prepare for encounters with beings whose very existence challenged earthly assumptions about life and intelligence? The road ahead. As humanity looked to the future, it recognized that the journey of intergalactic dialogue would be one of constant discovery and adaptation. The signals exchanged with the Luminae were a reminder that understanding was a process, not an endpoint. Each message brought humanity closer to decoding the language of the universe, but it also revealed the vastness of what was still unknown. The path ahead would require cooperation on a planetary scale, as well as an openness to new ideas and perspectives. It would demand resilience in the face of failure and the courage to embrace the unfamiliar. And yet, the rewards were limitless. For the first time in its history, humanity had the chance to learn not only about another species, but about itself, its potential, its limitations, and its place in the cosmos, inviting reflection. As the first chapter of intergalactic dialogue drew to a close, the questions it posed remained open-ended. What would humanity discover about the Luminae in the years to come? How might this relationship shape the evolution of human civilization? And what new forms of communication, understanding, and connection might emerge? These questions were not just for scientists or diplomats to answer. They were for everyone, for dreamers, thinkers, and everyday people who looked up at the night sky and wondered what was out there. As the broadcast from the ICA concluded, it ended with an invitation.